This is a short recording on odds ratios and exponential functions. And I want to do this in preparation for you to study logistic regression. So bear with me, and this will be something you can review as we go along. First off, I want to define an odds ratio. And odds of an event are represented by probabilities. It's the probability that an event happens divided by the probability that it doesn't happen. Now, another way to state that is to say, well, it's the probability of yes divided by the probability of no. Yes, it happens, or no, it doesn't. So then if you form an odds ratio for two events, you just calculate the odds of one event divided by the odds of the other. Quick reference to odds ratios, but it's a very powerful concept, and it's one that is very useful, as you'll see as we go along with logistic regression here. Okay, let's do an example. I'm going to look at the odds ratio here, and I've asked this question of male and female, and I've got the responses there of yes and no. It's 60-40 for males and 55-45 for females. And what I want to get to is the ratio of odds for male and female to see what that difference represents here. And so I'll do a little bit of calculating here. And first off, I'll calculate the probability of a yes for males. And you notice I use nice numbers, 100 in each category here. So it's easy to calculate the probability of a yes for males. It's 0.6. And so the probability of a no is 0.4. So the odds of a yes for males is 0.6 divided by 0.4 gives me 1.5. For females, the same calculation is 0.55 for yes, 0.45 for no, for a ratio of 1.22. So to get the odds ratio, I just take 1.5 divided by 1.22, and that gives me a result of 1.23. And what that represents then is that males are 1.23 times as likely as females to respond yes on whatever question this was in a survey. And that's a very useful tool, and it's something that I use quite a bit in the legal cases where I work. If I can represent the odds ratio of two separate events and translate that in and be able to say, well, this group is, 3 times more likely or 5 times as likely as the other group, it's something that is very easily grasped by your audience, and it becomes a very useful way to present information. So there is a shortcut. If you have a 2-by-2 table and you want to do an odds ratio, an easy way to do it is to cross multiply. Take 60 times 45 divided by 40 times 55, and you'll get that same result, that 1.23. So now you know all about odds ratios, and we'll talk about it some more as we go along. One other concept here, when we do cover logistic regression, you need to be comfortable with this notation. And so here's a few examples. If I have two exponential functions, e to the x times e to the y, you need to know how to calculate that or simplify it. If I've got their ratio, e to the x divided by e to the y, you should be comfortable with this too. And also with natural log of exponential functions, to be able to simplify the natural log of e to the x. And here's what those result in. E to the x times e to the y, I just add the exponents. To get their ratio, e to the x divided by e to the y, I can subtract the exponents there. For the natural log of e to the x, I can take that exponent and pull it out in front of the natural log function, and then it's equal to x times the natural log of e, but the natural log of e is just 1, so this simplifies down and it's equal to x. So just some notation there that I'd like for you to be comfortable with as we go forward, and that's just a short presentation, and I will stop my recording right there.